Hey there. I saw you there creepily staring at me, but I didn't want to interrupt. Nonetheless, I have something to tell you. A few months ago, I was reading an article about Starlink, specifically about the astronomical costs of its infrastructure. Pun intended. It seems it costs about $500,000 per satellite, plus the launch cost of $30 million per batch. All in all, costing more than $1 million per satellite to get them into orbit, Starlink intends to spend more than $6 billion only in its infrastructure. So I thought to myself, there has to be an alternative that costs just a fraction of the price and it can still be used to provide internet access to rural areas and during times of infrastructure collapse. I came up with an idea of using autonomous drones with solar panels to circle overhead 24/7. After all, how hard could it possibly be? Turns out quite hard. After coming up with a design in my head, I embarked in a journey that lasted for many months, but it concluded in a successful proof of concept. Coming up is a recorded video log of the whole ordeal. Please enjoy.
I'm here by my swimming pool diving board because obviously there's no better place to test electronics and high current voltage than near a body of water. Everybody knows that. So what I have over here is the electronic guts of what's going to be the solar plane, and what I want to test is this 50-watt solar panel that I got over here that we want to make sure that it is capable of powering two motors and also charge the battery. What I have here is a 3S battery, and to monitor the current I have a voltage meter, and over here I have a current meter connected to the rest of the system. So we should be able to monitor both the amps that are being drawn as well as the current that is being used. Alright, with that done, we're now back in my backyard right next to my swamp, because we can't really call that a swimming pool anymore. What we're going to do today is test the concept that we can broadcast a Wi-Fi signal from a long distance away. I have a quadcopter right here, and we're going to fly it all the way to the edge of the forest that I happen to have right behind my house, which is about a mile away, and we're going to see how strong the signal is from the distance. So let's get on with it. Over here, this is a regular plain old Wi-Fi router. This is what I use for my own home. I bought it for about 80 bucks in Amazon, and I brought it outside so that there are no walls between the service provider and the flying device. Obviously, this is not what we would use in the real world for a ground station, but this is only for demonstration purposes. And over here, we have the quadcopter, and right underneath, we have a Wi-Fi repeater. That is connected to the Wi-Fi router that I just mentioned before. This is broadcasting a different signal, but using the router as the gateway back to the internet. And this is what we're going to be connected to with my phone, and we're gonna see how strong the signal is. All right, as you can see, we have a whole bunch of Wi-Fis available, and the one that I should show you before is Gig South. All the ones that are related to my house are the ones named Gig something, and DroneNet is the one that is attached to the drone. DroneNet is connected to Gig South, and right now both of them have a signal strength of about minus 40 dB, which is fantastic. So let's see how strong the signal is when the drone is about a mile away.
All right, this is fantastic. The drone is about a mile away now, and the signal strength is really good. It's like minus 62 dB, which is, you know, super strong. As we all suspected, I wasn't smart enough to pull it off on the first try. It took me 9 months and 6 iterations to come up with a prototype that was aerodynamically efficient and integrated all the electronics as well as the solar panels. I didn't want to make this video eternally long, so we're going to skip ahead to the full systems integration test of the last iteration of the prototype. Alright, so we are here at the farm to see something spectacular today. We have a full prototype ready, so we're either gonna see a successful demonstration or we're gonna see a massive failure. Either way, it's gonna be spectacular. The prototype has everything on it. It has VTOL, it has solar panels, it has internet, it has everything. So it's gonna be a full systems integrated test today. As usual, I am here by myself, so I have quite a few things to do, more than usual, I would say. I have to fly the plane, and I have to use and test all the internet-related equipment, and I have to film everything on top of that. So it could end up being more of a disaster than I expected it to. But nonetheless, I will give it my best. So let's get started. So the plane is flying overhead, but the clouds are way too low, so we can't see it from here. But what we're gonna do is we're going to get in the car and drive about 5 miles from here and then check the internet connection to see how it works. Let's get on with it. Alright, so the plane should be flying out there probably around 5 miles, I think. I'm gonna double check when I get home. It's flying kinda low, so the angle that we have from here to the antenna is in a very shallow angle, but nonetheless we're gonna give it a try. So I have my phone right here, and first of all I'm gonna set it to airplane mode. There we go. And I'm gonna turn on the Wi-Fi. I'm gonna go to settings and connections, and as you can see, the Wi-Fi is connected already to DroneNet, which is great. And then what I'm gonna do is I'm gonna do a quick speed test. properly. Okay, so let's see what we got. Not bad at all. Actually, it's much better than I expected. 95. The hypothetical maximum that we should be getting is around 120, so 95 is not too bad. Now, let me go back here and let's see. Yeah, this is the only, we're in the middle of nowhere, and as you can see, the signal strength is minus 36 dB, which is fantastic. It's working perfectly. This is the best test that we've gotten so far. So, yay! Success! Yeah! Come on, yeah! The prototype works! That said, I still think we need a ton of improvements on the hardware, the software specifically related to coordinating multiple units, and the manufacturing process. But for now, I have to go. My planet needs me.